Thermal paramagnetic oxygen analyzer. Excess air optimization part 8. Fresh air as a calibration source. Dry atmospheric air contains approximately 20.95% of oxygen by volume, 78.09% nitrogen, 0.93% argon, plus trace amounts of other gases. The fact that air can be relied upon to be about 20.9% oxygen is often utilized by using fresh air as a calibration source for oxygen monitors that operate in the percent oxygen range. Magnetic susceptibility of various interfering process gases compared with oxygen. This is the heading of the table which has been shown for your reference. Oxygen is paramagnetic, meaning that is strongly attracted to a concentrated magnetic field. This uncommon property called paramagnetism is shared by a few other gases such as nitric oxide, which has a susceptibility of about 43% of that of oxygen. The table is attached. In the table, paramagnetic gases are listed with a positive sign, whereas diamagnetic ones have a negative sign. In a paramagnetic oxygen analyzer, it is required that the paramagnetic property of the background gases be constant in order to permit the accurate measurement of oxygen concentration. The paramagnetic property of gaseous oxygen has been utilized in the three basic types of industrial oxygen analyzer designs. One of them is thermal design, that is magnetic wind type, which we are going to discuss in this lecture. This diagram shows measuring element in a thermal paramagnetic oxygen analyzer. Request: it is hoped that this session is going to be useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा. The thermal design magnetic wind depends on the flow of oxygen in the sample being directed by the magnetic field of a permanent magnet, and also on the decrease of the paramagnetic effect as the temperature of the paramagnetic gas, that is oxygen, increases in the vicinity of heating resistors in the sensor. A flow-through type of ring element is illustrated in figure attached. In the case of the flow-through element illustrated, the paramagnetic oxygen content of the sample after it enters the ring is attracted by the magnetic field in the horizontal tube, where heating resistors heat the sample gas. Oxygen loses its paramagnetic quality when it becomes hot. As the oxygen in the heated sample loses its paramagnetism, more oxygen is attracted to the magnetic field, increasing the gas pressure there and displacing the heated oxygen, causing it to flow toward a space of lower pressure, thus forming what is called a magnetic wind. The magnetic wind flows out across the sensing resistors. The heating and sensing resistors are connected in a Wheatstone bridge circuit to detect the resistance variations resulting from changes in magnetic wind. The flow rate of the magnetic wind and its effect on the temperatures of the resistors are a function of oxygen concentration. Therefore, the Wheatstone bridge output signal is indicative of the oxygen concentration in the sample gas. Because the heating and cooling of the resistors is not only a function of the flow rate but also of the gas composition, affecting the thermal conductivity and pressure, errors can be introduced by variations in these properties. The presence of diamagnetic materials, that is, some other types of gases, can also introduce errors by affecting the magnetic wind. Errors can occur as a result of a change in sample pressure because the magnetic susceptibility of oxygen varies as the square of the static pressure. Some manufacturers offer pressure compensation in the form of special cells with compensating resistors that are also made part of the Wheatstone bridge circuit. Other suppliers require that precise pressure regulation be provided within a few inches of water. Variations in barometric pressure can also cause measurement errors of up to ±2% on narrow ranges, because the effect of atmospheric pressure change is about 0.02% oxygen per inch of water, that is 250 Pascal. Request: it is hoped that this session was useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा।